What a great morning so far over the Pacific Ocean. We got to see the first bites out of the sun from the moon. Just an incredible view so far. I really want to thank all the teams that are out there all over the country helping us to get the most science we can get from here. Really going to be an inspirational day and hopefully inspire the next generation of scientists, engineers like me even, in the current generation. Pretty inspirational from that standpoint. Volunteers everywhere, so we're excited about what's going on. And I got to turn it over to my buddy Thomas here. This is his field of study. So Thomas, what do you think so far?
Oh, it's amazing. We're already seeing it happening, right? Why do you think this is important to NASA and the United States?
Well, for us, it's a great opportunity. The totality across the continent, we're going to learn as much as we can. We study heliophysics and astrophysics in NASA, and this is a great opportunity for us to learn even more and have every instrument we have out there available to us to try to understand what we're going to see for the first time in 99 years. So just very, very exciting to see what we can do here and the observations that we're going to get. Can't wait to see the science come in and all the different science we're going to get from here. So, everybody's going to learn something. So you tell me what you think you're going to learn, Thomas, having been studying this for your whole career.
Well, look, my field of study is the sun. And what's really unique about this time is the opportunity to see the solar corona, the atmosphere of the sun, during the entire time of the eclipse stitched together for 1.5 hours. And the sun, of course, is important because it's the most important star. Everything we learn about other stars we learn here first, but it's also a source of space weather and radiation. And actually on board this aircraft we have 2 instruments, one from Los Alamos and one from Space Environment Technologies, that make those very measurements of how this radiation affects us.
Yeah, and I think it's important. The more we know about the sun, the more we know about space weather, it'll help us protect our own spacecraft in the future. It'll also help us protect our astronauts as we send crew further, and our home planet in terms of what's going on here. So why don't you tell me what you think we're going to see today and what we're going to learn today through this just incredible event.
So one of the most amazing parts of this is really to see the star as a magnetic star. And what I'm showing here is actually a prediction of the space environment of the sun today by predictive sciences and 3D printed by applied physics lab. And it basically shows that these magnetic fields are there. And what's really going to be great today is we're able to test these models using observations from the ground that we normally don't have. And so this is really exciting for us.
Very good. We've got over 11 spacecraft and over 50 balloons going up. We've got airborne science like we're even doing here. On the G3, can you explain what we expect to get out of the spectrograph we're going to have here on the plane today?
So a spectrograph is basically taking the light of the sun, which is white, and spreads it into its colors. And what we're going to see is during the time of now and partial totality, we basically see during the partial eclipse, we see the radiation from the surface of the sun, the photosphere, and all colors are there. Well, when we're in total eclipse, what we're going to see is the radiation from the atmosphere that we normally really don't see that up close. And that radiation actually has 2 predominant lines. One is a really hot iron, and the other one is, it's hot because it's 1,000,000 degrees because of that magnetic field. The other one is helium, called helium because of Helios, the sun in Greek. So it was actually discovered during an eclipse, just like it today.
Very cool. So here we are about 30 minutes away from totality. But you can explain to me what you think from a spectrograph perspective. You're going to look out the window. What are you going to see there?
Well, so for me, the amazing part really is that we're able to, of course, see our star in its beauty. And I'm already kind of emotionally touched even now. But also, we're going to see how that eclipse, that the lack of radiation, this perfect cloud that the moon makes, affects the Earth and its turbulence. I'm really going to see whether we're going to feel it up here.
Very cool. All right, thanks, Thomas, and thanks for sharing everybody out there. I tell you, about 30 minutes away, we're going to measure as much as we can here, and I'm about to fight this man for a window seat. So when you get on an airplane and you look for a window seat, get your glasses on. We're going to look out here, and we're going to wrap up here from the G3 and send it back to Solar Eclipse Central. See you guys soon.